Well, hello, one, and hello, all. Welcome to this chapter, which is 2.8 Specialist Techniques and Processes for Polymers. It's a good idea with the specialist technical principles to know these areas for two materials. The specification says, like, you need to know one, but it's preferable to know two. So I think really woods and polymers are safe bets. The reason being is that you've probably done most of these processes before. Things like metals are fine, but because metal processes are a bit more specialist and they need a little bit more specialist equipment, it's less likely that you've worked with metals as much as you have done polymers and woods. So we're going to work through these ones. Okay, let's get into it. So cutting. Sometimes we call cutting wasting or subtractive manufacture because it means that we are removing material from like a big piece of stock form. So let's imagine here that we've got a lovely big sheet of acrylic, like say 3mm acrylic, the sort of thing you might use to make a little key tag or something like that. So we've got some tools over here. And we've got a Sharpie. And you might be wondering, why has he got those there? So I'm going to explain. So yes, Sharpie or pen, pencil, whatever. Now, the reason we've got this is because those are really good for marking out on polymers. The reason being, polymers, you can wipe them clean, and it's a little bit like using a whiteboard marker on a whiteboard. The ink does actually hold on the polymer and then you can wipe it off. If you use a regular fine tip pen like this, it doesn't work. If you use a pencil, it really doesn't work. So so we use we use sort of Sharpies and board markers for actually marking on the polymer. So I'm just going to write that here. Sharpies can actually mark directly onto the polymer. So I'm going to say e.g. acrylic here. So then pens and pencils. So these ones, it's better to use them with masking tape. In fact, you can only really use them with masking tape. If that's your only option, then yeah, you can get some masking tape and you can tape a little bit over this strip of acrylic and then you can mark on there. The advantage of that is that you can obviously remove the masking tape and that takes off the all the marking out areas with it. That's the disadvantage with things like Sharpies is sometimes they're quite hard to remove or you have to use chemicals which are potentially hazardous like alcohol or acetone to actually remove them cleanly. So that's the only thing to bear in mind. Okay, then on to cutting. So yes, you'll see we've got three different types of saws over here and these might look familiar. This one at the top we call a scroll saw. And this is great because it has a very thin blade. In fact, you know what? I'm going to do this underneath like that. So it's got a thin blade. And because it's got a thin blade, it can cut very intricate shapes. Yeah. You can actually cut surprisingly thick material. So if you had, say, 10mm acrylic, you could actually cut that with this. Yeah, and wide range of material thicknesses can be cut. And yeah, and it's quicker than using a coping saw. I mean, that's really the rule. I mean, any powered machinery is going to be quicker to use than manual. Okay, so that's the scroll saw. Now let's talk about the coping saw. Sorry, my font sizes are all over the place here. That pains me. Coping saw, yes, it's a very odd name, and it probably dates back a very, very long time ago. But coping saw, think of it this way: the coping saw copes with going around corners very easily. So we can put that in inverted commas because it's sort of a way of remembering it. Copes with corners and intricate shapes. Yeah, and actually the blade is removable. You can actually unscrew the handle and then you can easily take the blade out. So if you wanted to cut an internal shape, like let's say if you were cutting like a letter, like the letter D, and you wanted to remove the inside of the D, you could first drill a hole and then you could insert the blade through that hole and then reattach it to the saw, and then you can actually cut out that internal shape as well. So you can cut internal cavities thanks to the removable blade. Yeah. And they're a very like low skill piece of equipment, and they're relatively safe. Yeah. Okay. The next one down is called a junior hacksaw. So these guys are used with, in fact, these can be used with plastics or with metals. So the reason that they're good with plastics is they have very fine teeth on the blade. Now, the reason that this is advantageous is because when with generally, well, no, it always goes. The harder the material, the smaller the teeth on the blade need to be. So I'm going to write that here. The harder the material, the smaller the teeth. So junior hacksaws have very, very fine teeth on them, and this means you can actually put in, like, if you had, say, solid plastic rod, and quite a thick solid plastic rod, maybe 20 millimeters or something, you would use a junior hacksaw to cut it to length. They're better for cutting straight lines than coping saws, purely because they've got a slightly wider blade. So better for cutting tubes, rods, bars, with straight cuts due to the wider blade. Yeah, and these in the workshop, without using something like the laser cutter, these are basically the primary way that you would remove material. And yeah, we like I said at the beginning, we call this sometimes like wasting, subtraction. Sometimes even when it's a rough cut, we just call it roughing. Bring that to the front there. There we go. Yeah, sometimes it's called roughing as well. Okay, so yeah, that's really what you need to know for cutting plastics.